Hello, this is part 4 of the impulse momentum videos. In part 3, I showed you a classification of collisions based on geometry and what happens to the kinetic energy. Now, I'm going to go through that list in this video and solve a couple of collision problems. The first one in the list was head-on collisions. So let's start with head-on and elastic collisions, head-on and elastic collisions. Now, let me write the conservation law for momentum and the condition for the conservation of total kinetic energy first and see what I have. Now, remember, this was about two objects, like billiard balls maybe, moving only along the x direction. So the masses are ma and mb, and the initial velocities are va1 and vb1. Okay, they may be in opposite directions or the same direction, doesn't matter. Let's keep it general for now. From the momentum conservation principle, we have ma va1 plus mb vb1 as the total initial momentum. Now, I didn't put arrows on these because there's only one component to work with, okay? I'm going to do the same thing for the total momentum after the collision. ma va2 plus mb vb2. So these are the x components of those velocities, and this is the momentum conservation. Now, that's the head-on part. What about the elastic collision condition? That means the kinetic energy is conserved. 1/2 ma va1 squared plus 1/2 mb vb1 squared. This is the total kinetic energy before the collision. This will be equal to the total kinetic energy after the collision. va2 squared plus 1/2 mb vb2 squared. All right. Now, a typical problem will be, like you will be given the masses, ma and mb, and maybe initial velocities, va1 and vb1. And you're supposed to find va2 and vb2, the after velocities. You have two independent equations. This is solvable, fine. But the second equation is quadratic in velocities, and they're typically harder to solve, or it takes more time, not too hard anyways, but there's a simpler way. Now I'm going to derive another equation, which is going to be a linear equation, not a quadratic one, and keep using that equation from now on, okay? So here's how it goes. Let's call this equation number 1, and this is equation number 2. I'm going to take a second equation, and I'm going to first get rid of the 1/2. Let's simplify it a little bit. Okay, get rid of the 1/2. And then collect the A terms on one side and the B terms on the other side, so that I have here ma va1 squared, and then take this one and bring it to the left, minus ma va2 squared, and do the same thing for this guy here, minus MB VB1 squared plus MB VB2 squared, okay? You can also factor the MA and MB. MA VA1 squared minus VA2 squared equals, let's factor MB out. Let's also factor a negative out. So we'll have 1 minus 2, right? It'll look like the left-hand side. Negative MB times VB1 squared minus VB2 squared, okay? And minus sign and negative makes positive, so we're good. So let's rewrite the left-hand side. See, we have the difference of squares here, which means I can write it as MA times VA1 minus VA2 times VA1 plus VA2. Similarly, on the right-hand side, negative MB VB1 minus VB2 times VB1 plus VB2. Okay? So, let's take the momentum equation now, which is equation number 1. And let's group these terms the same way I did for the second equation. Means put the A terms on one side and factor MA, so VA1. So this is from equation number 1. All right, VA1 minus VA2, and bring this term to the right-hand side with a negative sign, negative MB VB1. Now I have plus MB VB2. There's a negative here, minus here, so I need minus over here as well. VB2. Okay, this is nothing but the first equation. But I see that the left-hand side is already here in the linear form of the second equation. And negative MB, VB1 minus VB2 is right here. But these two are equal to each other, so I can get rid of them. And I end up with what is left. Okay, what is left is this. VA1 plus VA2 equals VB1 plus VB2. Now, let's regroup this so that the 1 terms are on one side. VA1 minus VB1 will be equal to, now on the right-hand side, I have VB2 minus VA2, all right? But let's write it in the A minus B form, like the left-hand side. So pull out a negative, and VA2 minus VB2. Okay, so that's the new number 2. All right, the new number 2. It is linear. It's not quadratic. It still has the energy conservation in it, along with the momentum. So we're gonna still work with 2 equations, all right? Number 1 and the new number 2. But it's gonna be much easier to solve the equations, okay? You're gonna see in a minute when I do an example. So let's box these in red, and we're gonna be using those from now on. This equation here, and the one that we started with, the momentum conservation. But keep in mind, this equation here, the new number 2, can only be used for head-on and elastic collisions, okay? It has to be head-on and elastic. If it is head-on and elastic, you can't use it. If it is glancing but elastic, you cannot use it either. It has to be both head-on and elastic, all right? That's the only case, that's the only time you can use this simplified equation. And that equation does not have any mass in it. See? There's no mass here. And also, the left-hand side is the difference of two velocities, okay? It's like a relative velocity. Like if you want to find out how fast one object is moving with respect to another one, you know, if you're an observer who is traveling with the second object, that kind of idea. So that difference of velocities are present on both left and right hand sides with a negative sign, okay? So let's solve an example, a head-on elastic collision, okay? So to make it even simpler, let's take MA and B equal to the same number, like they are in billiard balls, all right? So example, let me switch to mine here. Okay, so here, example 1. All right, let's say this is ball A with a mass MA, and here is ball B, MB, and MA and MB are the same, let's say. I'm going to show you examples where they're not the same, but for now, let's keep it simple. Let's say this billiard ball is moving to the right with 4 meters per second. All right, this will be VA, VA1. And let's say MB is stationary, just sitting there. VB1 is 0. All right. So, what are the after velocities? Okay. Let's apply equation number 1. Now, the masses are the same, so I'm going to cancel those masses. All right. Just write the velocities now. VA1 is 4 meters per second, and VB1 is 0 plus 0. I'm just using the first equation, right? On the right hand side, I have two unknowns now. VA2 plus VB2. Now use this one. Okay, VA1 was 4, VB1 was 0. On the right hand side, I have negative VA2, negative minus makes plus VB2, okay? Let's solve these for the unknowns, which are VA2 and VB2. Now, whenever I see two equations like this, I immediately think about adding them up, because this is the VA2, this is negative VA2. I know if I add them up, I only have 2 VB2s here. So if I do that, add this equation to the second one, I'll have 8 meters per second on the left hand side. This will cancel that, and 2 VB2s on the right hand side. Dividing both sides by 2, I'll get VB2 equal to 4 meters per seconds. Now I take this and plug it in either the first equation or the second equation. 4 equals VA2 plus 4, which means VA2 is 0. VA2 is 0. So the first ball stopped and gave all the momentum to the second ball. Now the second ball is moving with 4 meters per second. It's positive 4, which means it's moving to the right. Okay, let's do another one. Let's just add an initial speed to the second ball. So example 2, again a head-on collision with the same balls, M and M. They have the same mass, right? Now this is moving with, let's say, 5 meters per second, and this one, let it move to the left with a speed equal to 3 meters per second. What are VA2 and VB2? Okay, same problem, but now the second ball is not stationary, but it's moving to the left with a speed equal to 3 meters per second. All right, so same idea, same equations. The first equation, momentum equation, and the second is this equation. All right, for the momentum equation, I have the masses cancelled because they're the same. I have 5 meters per second for VA1 plus, now I need VB1, right? But VB1 has a magnitude equal to 3, but it's to the left. So the component of the velocity is negative. So I'm going to write negative 3 meters per second. Right hand side, again, VA2 plus VB2. That was the first equation. The second equation, let's take this here. Second equation. Now I have VA1 minus VB1, right? So 5 meters per second minus negative 3 meters per second. This will be equal to negative VA2 plus VB2, okay? So just like these equations here, the right-hand sides are the same. The left-hand sides I replace the 0 with negative 3 meters per second. So what do I get here? On the left-hand side here I have 5 minus 3 equal to 2 meters per second. And here 5 minus negative 3, 8. 8 meters per second. I'm going to do the same trick. I'm going to add these two and get 10 meters per second on the left-hand side. On the right-hand side, this will cancel that, and I'll have 2 VB2s. Therefore, VB2 will be equal to 5 meters per second. Now take this 5 and plug it in the first equation. Let's say 2 meters per second will be equal to this unknown VA2 plus VB2, which is 5 meters per second. And if you solve this for VA2, subtract 5 from 2, you get negative 3 meters per second. Now, negative means it's moving in the opposite direction, to the left. Okay, so VA2 will be to the left. Ball A will end up moving to the left after collision, and B will end up moving to the right after the collision with 5 meters per second, and this is with 3 meters per second. So what happened? I mean, this was the speed of B before the collision, and 5 meters per second was the speed of A before the collision. They swapped their velocities, okay? And that's always the case if the masses are the same for a head-on and elastic collision. It was the same in the first example too. It was 4 and 0, and now it is 0 and 4. They swapped their velocities. Same thing happened here. All right, this was example 2. Let's do another one, example 3. So let's change the masses now. All right, let's see if I have room here. Let's say example 3. Okay, let's make room here. So I'm going to change the masses. Let's make this 10 grams. 10 grams. This is MA. And MB, let it be 30 grams. Okay? And let VA and VB. Now again, I want these two to approach each other, let's say, with the same velocity. How about 2 meters per second? So VA is moving to the right, A is moving to the right, 2 meters per second, and B is moving to the left, negative 2 meters per second. So based on these given numbers, what are, I guess I have to say VA1 and VB1, right? And based on these, what are VA2 and VB2? All right, so let's apply our two equations one more time to see what we get. From the first equation here, now I'm going to include m's because they're different, right? MA and MB are 10 and 30 grams. Usually, you would convert your grams to kilograms, but in this case, don't bother doing that. They appear on both sides, just write the gram values. So MA is 10. I'm just going to write here 10. I'm not going to write the units to save space. So 10 VA1 is 10 times 2. 10 times 2 plus, now MB is 30. And VB1 is negative 2. Now I'm on the right hand side. MA again, 10 times this unknown, VA2 plus MB 30, VB2. This is the momentum conservation. And from equation number 2, or the new number 2, VA1, which is, see, there's no mass in the second equation, right? VA1, that was 2, minus VB1, that's negative 2. Now this will be equal to negative VA2 plus VB2. All right, so let's solve these now. In the first equation, I can divide everything by 10. All right, let's do that. I'm just going to get rid of these zeros here. Get rid of the zeros only. Okay, so I have only VA2 here. I have 3 VB2s here. I'm just going to add them now. Like I did before. So here I have 2 minus 2, that's -4. -4. And here I have +4. So +4. 2 minus 2. Oh, sorry, that's 2 minus 2. That's 0. Pardon. So this is here. All right, let's switch to, okay. So, no, I'm sorry. It's 2 minus 6. It's negative, it did -4. Why did I, okay. I was correct in the beginning. Okay, -4. 2 minus 6 is -4. Okay, on the right-hand side, these two cancel. And then 3 plus 1, 4. 4 VB2s. The left-hand side is 0, though, which makes VB2 also equal to 0. Now take that 0 and plug it in either this or that. So this will give you VA2. Okay, if VB2 is negative is 0, it's negative VA2 is 4. Therefore, VA2 is -4 meters per second. These are the velocities after the collision, right? So the heavier object, MB, just stops. And VA2 starts moving in the opposite direction, doubling its speed, all right? Okay, I'm going to stop here.